Okay, in this exercise, we will make this pipe knee or pipe coupling, whatever. So, and the idea is that we use the revolve feature as a base feature to make this segment with a 45 degrees revolution. So, all what we will need to do is to make the two circles and to revolve them, or one circle and to revolve it, and then to use the shell. However, as it is dimensioned, it will be better to use the two circles. So one with the 137 diameter, one with the 88 millimeters diameter, and then to have somewhere here the center line, which will be offsetted for the radius of 225. So I'm going to start here actually by making that sketch on a front plane and by making a center line, vertical center line. Now I'm going to make a circle which is going to be of the diameter 137, and the distance between the center line and the circle will be the radius of 225. And I'm going to make that the center point of the circle is horizontal with the coordinate origin, which will complete this sketch. I'm also going to make an inner circle with a diameter of 88 millimeters. And that's all what I need to sketch to make my 45 degree knee. So now I will just do the revolve boss base. Okay, so revolve boss base. And I'm going to, instead of the 360, first I'm going to make it as a mid plane. And I'm going to choose here 45 degree. And look, I have made the key piece of this part. And where it is, the key piece is this 45 degree segment of the pipe. Now, I'm going to extrude out 225 by 37. I'm going to extrude out, as you can see, it's tangential, so it's just extruded out. Well, so I'm going to extrude the two flanges, and they are the 225 by 37. So I'm going to make a sketch here, and I'm going to make the circle, and I'm going to make this circle to be outside diameter of 225. I'm going to make this circle to be coincidental with this circle here, concentric, not coincidental, but concentric. And I'm going to change this circle to bring it this edge, to convert entity, to bring it to my current sketch. I'm going next to extrude this out for the 37 millimeters. And then I am going to do the fillets of R15 and R10. So let's say the R15 fillet is here and R10 is outside. So there will be two fillets, 15, and another fillet, which will be 10. Let's see. Now, how I will copy these features to the other side? Well, I can use my front plane to do the mirror. And if I do the mirror, I can actually, by front plane, I can choose the features to mirror. I can choose this feature, and this feature, my latest two fillets. And look what happened. I am practically done with this piece. There is one more thing to do here. There is like a little this extrusion, which is not really defined how much it is. So it's actually 47, and we know that this is a 37, so it is a 10 thickness with a diameter of the 130. So on this face here, on the face on the closer flange to us. I'm going to make a circle, which I'm going to make to be a concentric. Going to specify the circle diameter to be the 88. Oops, actually, let's see, is that the, no, pardon, the 130. 130. And I'm going to convert the inner circle, the hole, the edge of the hole, to bring it to the, and I will extrude it out for a 10 millimeters. And I can make this to be, for example, from the cast alloy steel. And here is our pipe coupling. And we can hold and we can evaluate its dimension. And its mass properties are 29,997 kilograms. Okay, so we've seen now an example of something that initially may look confusing, but actually it's a very simple revolve. Revolve, we also need to think in a multiple planes and multiple directions. So in this case, the revolve orientation was just a circle with a straight line on a front plane, and on the top plane it will result into this bended knee kind of a figure. Okay, so let's now do it.